So we are in our part 4 of our video series on special shear wall design using ETF's program. In this video, we will be discussing or leading you through the general Pier section method in ETF's program. We have previously discussed with you or tried to convey you a message that CNT method may not be applicable in all the cases because you are losing the middle reinforcement or distribution reinforcement here. And also, uniform reinforcement method is useful to you to get some idea what type of reinforcement you may need to provide. For example, after designing this wall using the uniform reinforcement method, I got an idea that using 20 mm reinforcement will be sufficient for the flexural design. Also, if I click on the wall, then I will have some other information here. There are some legs. I will talk about the legs later in other videos. Here, some of the data that may be useful to you is the shear design. We will cover it later. Boundary element design, we will also cover it later. But here you need some information here that the boundary zone table, how much boundary zone length you need or edge length you need. For example, the maximum length you end up getting is 27 or 28 inches here, right? So it means that if you provide 20 mm at the rate of 4 inches on center, then you can provide it. However, up to 28 inches, right? Up to 28 inches on certain leg of your wall, because there are 4 legs, and I have not made it clear to you, which is what leg. Maybe I should make it clear to you now. Leg 1, 2, 3, 4 has some information here. Say leg 1 is has x1 and x2 coordinate 424. So we can find the leg 1 very easily. So say leg 1. Let's go to the plan. So this data, if we check it in inches, it is 424. The upper point is also 424. So if I take a snapshot of the wall and take it to the paint, then this is the pier number 1 or leg number 1. Okay, and then leg number 2 has x coordinate 424, 502. Let's take the common coordinate 378. 378 is the y coordinate. So y coordinate is 378. So what is this? This one is 293. This one is 378. So this is the second leg. And then leg 3 is it has a common coordinate along x. It is 502. What is 502? X is 502. This one is 502. So this is 3. There is another one left. This should be the fourth one. Leg 4, 424. 293 is the common coordinate along y. So along y it is 293. So this is 4. So considering it another leg is actually useless because it works as the boundary element of 1 kind of. So disregarding 4 would be better. However, let us carry out our instruction video considering it a leg as well. So let's go to the boundary element table again. Here, in your leg 4 is very small. You need 7.5 and 7.5 inches from each edge boundary element. Actually, we will consider it completely. It will be a boundary zone, boundary element. We are not going to divide it into some boundary zones. Whole of it will be a boundary element. Okay. Then leg 3, let's go to leg 3. Leg 3 has 27 inches demand here and here. So 20. So this is a piece of information which is useful to us. 27 inches, right? 27. And then for leg 2, they need 21 inches. 21 inches. So, and then leg 1 is 28 inches. This is the leg 1. And the important thing which you need here is the length. Length is given here. Length is 103 inches for leg 1. So this is the leg 1, right? Let's say this is the leg 3. Okay, leg. So leg 3 has a length of 85 inches. So let's check it out. It is 378. It is 293. How much is it? 378 minus 293, you get 85 inches. So there's a actual model length which you have modeled here. So that's center to center length. So the boundary zone which is indicated here is from the center towards there. So since the wall thickness is 14 inches, so when it says that the required boundary zone is 28 inches, then you deduct 7 inches from your 28 inches, then remaining portion is into here. So for example, 28 minus thickness of the wall divided by 2 is 7. 28 minus 7, 21 inches. From this edge, we need to provide 21 inches boundary zone here. So this is another piece of information for us. So what we want to do is we do not want to provide uniform spacing along the whole length of our wall. We can provide some dense reinforcement here at the rate of 3 inches center to center, or or say for example 4 inches, or maybe we can use 25 here at the rate of like say 4 inches, and maybe we can use some central reinforcement like this, right, like this, and maybe if the width of your wall is pretty wider, then you can use 2 rows of additional reinforcement inside here, right? You can do that, no problem in it. But this thing will not be covered by uniform reinforcing method. Okay. And provided reinforcement spacing here at the distribution area will be high, will be 5 inches, 6 inches, or 8 inches. Someone might choose 12 inches, whatever. Depending on the minimum code requirement, they should fulfill this as well. Okay. Then now we will take you through the general fire section. Okay, let's do that. Since we have assigned here some uniform reinforcing, say this 20 mm 4 inches, 2.5 inches is the clear cover, etc. If we now assign here a general reinforcing, then the model will ask us what is the fire section you want to choose. So we have to make a fire section first. So the fire section will can be made here. Define general fire section. We have our fire section already made for this structural shear wall. But I want to take you through this a little so that you can make it on your own. So you will have to make it afresh. So let's call it fire one. Fire one. Is the case one. And the base material is the 3.5 KSI we are using for this project. And you will choose here, start from existing wall pair. It will be story number will be PL because this is the cleanse level. And pair name we have assigned here P1, right? So this whole wall has P1. So you will choose P1. If you have multiple shear walls, say you have 10 shear walls in your building, this has P1 name, others have P2, P3 names. So for this, if you make your general pair section, you will choose P1. For another, if you make another general pair section, then for that, you will have to choose that particular pair level. Okay. So pair level is found. And then you need to go to the section designer. So you see that the wall is drawn in scale exactly in the general part section or in the SD section platform. So this part is actually this, right? And this is this. So this is a little, it's oriented in the SD section, so nothing to be worried. Don't think that you have to model it like this, okay? So modeling will depend on how ETFs auto generates it. Otherwise, you are going to change everything. Your wall is located like this. If you make the general part section in your way, you start drawing it from scratch and draw a shear wall or general part section exactly like this here, then you are actually making mistake. Okay. So you have to consider this, that the general bias section or the SD section which is developed by the ETFs model is correct. Though it may be it may have a different orientation than your model. It may have, it doesn't matter. Okay. So what you need to do is, um, what is it? Okay, this is the general price section we are making, right? Okay, let's make it. So you cannot actually change the reinforcement here. Bar size is, you can change probably. Let us check 25 mm. You can, if you change one, then probably one row is completely changed. Then if you change this one, say I make it 32 or 40, 50 mm diameter, then a row is changed. So you have less control in this general power section that is auto generated. Uh, Most importantly, you have less control on your reinforcement. So what can you do? You cannot even delete this reinforcement. If you select this and delete, then everything is deleted. Your concrete section and your rebar, everything is deleted. So you have got the idea that I don't really like it. What we need to do is we need to draw this same shape again. Okay, what I do, I'm showing you that. You can follow it. So you need to click on these snaps, and there may be another snap activated. Okay, let's do it. Let's draw it. It takes time. However, I advise you to restart your, PC if it is on for a very extended period of time, because if your graphics is slow, it may take pretty much time. Okay, my cursor is lost. You see, it's lost. So what I have to do is I have to click on drop polygon again. Then it will be deactivated here, 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 here. So I have drawn a wall. So how can you understand that I have drawn a wall? So let's replicate it to say 100 inches above. I don't know which one we moved, which one will be moved. The new one which I have drawn has been moved. So I will delete this previous one. Okay, has it been deleted or not? Delete it. Okay, then select it and then replicate it to negative 100 to bring it back to its original position. Okay, okay. Let's say select OK and then OK, and then save your model once, so that your work doesn't get lost due to some minor accidents you make while you make this prior section, and then go there again. Now what I'll do is I have got a preliminary idea of how much will be my fire, edge zone or boundary zone. So I have got an idea. It should be 28 inches, right? And from corner, it should be 21 inches like this, 21 inches like this, 21 inches like this. And it will be this corner, this portion, it will be fully a boundary zone. And from this point, it will extend 21 inches to the left. And from this point, it will extend 21 inches to the bottom, 21 inches to the top, 21 inches to the left. And this one will be completely a boundary element. And from this point, we will extend the boundary element 21 inches towards the right. Okay. So this is our basic idea, or how we want to do that. Okay. So let's say you have done it. So I'm not going to spend a lot of time, because it takes a lot of time. It takes hours to draw it. I have drawn it for your demonstration purpose. I have drawn a reinforcement code here. You can see of, I don't know what they are showing me. Let me deselect this all and then right click here. I think you should show me the reinforcement. And so it looks like I can't right click on the rectangular bar. So what you need to do is you have to click on control. You have to type on control, keep your finger on the control button, and then right click at the middle, then click on the rectangular bar, then you will get the geometry. Geometry is 8 inches because it is 14 inches total. Then I am deducting the clear cover. So clear cover I have considered 3 inches from the edge to edge. So you can consider 2.5 inches. So from 14 inches, if you reduce 3 plus 3, 6 inches, then you will end up getting 8 inches. And this one is 21 inches. However, since here we have additional 3 inches, then it will be counted as 24 inches boundary element. So 8 by 21 inches. And the reinforcement information is here. I have provided a 20 reinforcing at the rate of 3.5 inches spacing. Okay. And if I had wanted, or if I had required, then I could have I could have added some additional reinforcement here as well to make my shovel pass. However, it's not required for me. So what do you need to do? You need to draw your reinforcement here. So since it's a boundary element, there will be higher reinforcement. So you draw this, this, and that one, and then draw your distribution reinforcement gauge, one here, one here, one here. Okay, so for example, if I take you to the distribution reinforcement and show you the details, then you can see that rectangular bar is this one, and then is 23.5 inches long, and the rebar is 12 at the rate of 5 inches spacing. So what are the things I have done in this general part section? I have provided higher or dense reinforcing at the edge zone of the boundary element at 3.5 inches spacing, and I have provided lower, lighter reinforcement here and higher spacing. So this thing, you cannot do it in your CNT method or your uniform reinforcement method. You have to revert to this general pattern reinforcement. Let's say you have drawn this, okay, and then what you need to do is you need to reduce these distances. Say for example, the distance is very high now. You have to make it close to each other. Say for example, if it is, I don't know, it is 11, it is what, 16, 5 inches gap, you can bring it 2 inches to the left. Okay, so there are a lot of things you need to do after drawing this. So I think it's not a very hard thing for you to draw it. You can draw a reinforcement cage from here, draw a rectangular bar, and then say I want to draw the rectangular bar here or here. Say I want to draw it here. So at first I will draw a reference line like this. Okay, like this. I have drawn a reference line. Then I will zoom it, and then I will go to the rectangular bar. I will take the center and then draw it. And then I know the size. The size of this is x equals 0, y equals 67, and y equals 92. 92 minus 67 gives you 25 inches. Air cover should be deducted. 2.5 into 2. So you get 20 inches. So height shall be 20 inches. Width shall be 14 minus 5 shall be 9, should be 9. So like this, you have drawn this, and you can delete the previous one, probably this. So how can you do that? Control and then left click of your mouse. And then select the polygon 3, you can follow. I will select the rectangular bar 1, okay, and then delete it. Then I will end up with my new one, I guess. I don't know. It is a new one. No, I don't think it's a new one. I will do this. I will select again control and then left button of the mouse. It is probably rectangular bar 4, the older one. I don't know. Yes, it is so. Then you can change the bar spacing from here, bar size. You can choose 20 or whatever dia you need in your structure. Then change the spacing here. Then the number of bar will be automatically changed based on the spacing. You don't need to do anything, and apply to all edges. Then based on 3.5 spacing, all the edges will be changed. You need to change the corner bars separately. For example, there will be 20 bars. So done. Then again, if you want to draw this, so what you can do is you need a point here, right? So you can draw something like, say, for example, I will go from this line, I'll go 21 inches. So how can I do that? I can draw a reference line, probably first, and maybe snap it to everything. Okay. And then probably I can select it and then replicate it, then probably 21 inches or 24 inches, and then make it 0 and then delete it. Then I don't know whether it is drawn or not. Yeah, it is drawn. Yeah, here. Okay. Then what I can do is I will draw again another reference line or reference line, and then take this. Yeah. And then I got the midpoint here, right? Midpoint. I can then uh, delete this or redraw with respect to this midpoint, I can draw this shape again. Okay. By doing this, you can draw your general fire section. I think uh, it takes time, but it's not difficult. Now, there is an issue. What happens most of the times when you use a general fire section, the model says that, okay, I'm not deleting this um, things. Okay, so maybe the name is Fire 1. Say I am assigning Fire 1 to general reinforcing, and then Fire 1 to the bottom of my wall and to the top of my wall, and I am asking that reinforcement to be checked. So I will get a demand capacity ratio. So design it. The model says that unable to calculate interaction diagram for section. So how can you get rid of this problem? You can get rid of this problem easily. What you need to do is you need to go to the define general price section again, Fire 1, go there, and go there. You can make a copy of it so that you can keep the original one so that you can make changes in it. Okay. So let's make it Fire 1, is the PMM issue solve. Uh, okay, then general price section. What you need to do is you need to select all the reinforcement and all the everything you can select, then change bar shape to single bar. You can do that. What happens now is you can select individual bar and change the individual bars. However, I think you know about it. I am not going into in detail in it. So now is the fire 1 PM issue solved. Now what we need to do is we need to reassign it to our wall, general fire section, PMM checked. So do it. And then now it's okay. Your wall is now it can the model now can calculate the PRM interaction diagram. So you see that when we use the uniform reinforcing at 4 inches spacing, 20 bar, we had 78%. The demand capacity ratio. Now we have it 76% because more or less we have kept the reinforcement same. We have used some distribution reinforcement. However, we increased the amount of reinforcement at the edge. We used 20 at the rate of 3.5 inches spacing. So this video must be good enough to give you an idea that general reinforcing design is actually good for you when you are checking another design done by someone else. When you are assessing an existing structure, then you should go for general reinforcing. If the reinforcement spacing is not uniform, then you should go for general reinforcing. Okay. Okay. I hope the video has been helpful to you. Thanks for being with me, being with us. Okay. Bye.